Okay, this is Professor Thompson again, and I'm going to do some more examples of the chain rule, and now I want to talk about mixing the chain rule with the product rule. So, the first example I'll do, that can happen in two different ways. The first way, I'll do an example 32, and this is when the chain rule happens while you're doing the product rule. So, this is 32 in section 2.5, and it's y equals x sine 1 over x. And I want to take the derivative here. So you see that the outermost thing going on is that there's a product, right? It's x times sine 1 over x. So there's my a and there's my b. Before I take the derivative, though, I'm going to write 1 over x as x to the minus 1, just to make things more clear. So now I want to try to take the derivative, and so I need to use the product rule to start. So if a is x, a prime is 1. And if b is sine of x to the minus 1, then I need to use the chain rule to do this derivative. So the outside function is sine, because it's sine of x to the minus 1. So the last thing you say when you use the phrasing of is the inside function. So the outside one is sine. So it's cosine of, and I leave the inside argument, and then I multiply by the derivative of the inside argument. So this is minus x to the minus 2. So now there's my four pieces, and I need to put them together to do the derivative. So I'll go ahead and do that on the next slide here. So if y is x sine of x to the minus 1, then there's my a and b. And so I want to say dy dx is a prime b plus ab prime. So a prime was 1, and b is sine of x to the minus 1. And then a was x, and b prime was that thing we found with the chain rule, cosine of x to the minus 1 times minus x to the minus 2. So you could do some simplification there, but that answer's fine. Okay, so that's the first thing that can happen is you encounter the chain rule during the product rule. The other thing that can happen is if you do the chain rule, the derivative inside might be a product. So let me give you an example of that. So this is just one I've made up, and so it's x sine x all cubed. Now you could cube both individually and then revert it back to the previous situation, or if you want to do the chain rule first, then this is the cube of x sine x. So this is the inside function, and then the outside function is x cubed, because x sine x has been put into x cubed. So to take the derivative, it's 3, and then x sine x stays, and the power rule lowers it down to 2. So I did the derivative of x cubed, but I left x sine x inside, and then I multiply by the derivative of x sine x, and that takes the product rule. And so the derivative of x is 1, and then b is sine x, and then I write x, and the derivative of sine is cosine x. And so there's your derivative, just to clean it up a bit. I've got 3 x sine x quantity squared. You don't need to expand that. And then it's sine x plus x cosine x. And that would be your answer.